Welcome to this part's presentation. Today we're going to be looking at Altium libraries, lessons learned. Before we get started, just a little bit about myself. My name is Randy Clemens. I'll be your host today. I've been using Altium since version summer 09. I've been using the tool for about 12 years now. And I'm going to be demonstrating using database libraries, but we're going to also be discussing all sorts of libraries, symbol-concentric, integrated libraries, database libraries, and Altium 365's managed components. We're going to touch on Access and Excel database libraries, MySQL databases, and we're also going to look at Altium 365 managed components. We're going to discuss a little bit about mechanical layer usage in footprint libraries, courtyard settings for best results, and suggestions for polarity dots that will make cleaning up your silk screen easier. We're going to discuss some parametric data, how you might structure your parametric data to get the best results in Altium. And we're going to discuss a little bit about BOMs, BOM templates, and using Octopart. Also going to look a little bit at alternate parts and supply chain issues. Let's get started without further ado. Okay, the three basic elements to PCB design libraries, of course, are symbols that we place in our schematics and footprints that we have on our circuit boards for layout. And lastly, there's our parametric data that we want to put in our BOM. So here I have an active BOM, and here's a BOM for this simple demo project. Okay, of the different library types, you can have what's known as a symbol-concentric library. That's where the parametric data and the footprint are housed in the symbol file. And so here we can display our footprint. We can point to a footprint by name. We can have multiple footprints if we like in the symbol. And we can have parametric data as we like. The main problem with symbol-concentric libraries is that they're not easy to collaborate and they're tedious to maintain, requiring quite a bit of work. For example, if we wanted to make an additional resistor, we have a 1K resistor, we might start out by copying that 1K ohm resistor and then changing some of the data in there, being careful not to forget to change the supplier part number, the manufacturer part number, the manufacturer, and any other information that we might have that's pertinent to that part. Anyway, it's a bit error prone. Can be done, but it's a bit more error prone than, say, using database libraries. Also, it's very hard to collaborate because once a user opens a file, a library file, a concentric library file, and saves it, if another user has the same library file open and is editing or adding another part, the last person to save the library will overwrite the other user's work. So it's very similar to what happens with any document where two users open it at the same time, try to edit it and save. There's going to be a conflict. Someone's going to lose their work. And that's what database libraries and also Altium's 365 managed components attempts to solve that problem. You can also use integrated libraries. Integrated libraries, to demonstrate that, we're just going to take this design and we can very simply make an integrated library. And for those who don't already know, an integrated library just takes the footprint that's on the symbol that's in the schematic, the footprint that's on the board, and the parametric data, and merges that into a integrated library. So we'll find that after doing it over here in the compiled library, and we've got now a integrated library. That integrated library probably shows up also in the components panel immediately after creating it, and there it is. For some reason it didn't seem to pick up the footprint very well. Seems kind of odd. I'm not sure what happened there. Could be there's a bug in the latest version of Altium for creating integrated libraries. I'm kind of surprised, but anyway, in an ideal situation, that would have created an integrated library that would contain both footprints, symbols, and the parametric data. We'll go ahead and close that for now. And unlike an integrated library or a symbol-concentric library, a database library has pointers to files, to the symbol file, a pointer to the footprints, and parametric data. So a raw database might look something like this. This is an access database. We can select, I'm going to be using this parts front end. This is not necessary for using a database library to have a parts front end, an application like this, but it certainly makes it a lot easier. I'll demonstrate that and how to use a database library with or without this tool along as we go. Anyway, if we hit the Explore button here, I'm going to be able to open what's called the back end. And the back end is where the actual database lies. So if we open that up and we were to look at the database in Access, we'll see that it just looks a lot like an Excel spreadsheet. It has rows, columns. In database lingo, however, the headings for this is a field, known as a field, and a row is a record. But anyway, in Altium, the field is referred to as a parameter, and these are just another parameter, but in database lingo, those are fields, so you may hear that word once in a while. And so all a parts client or front-end application like this one does is it just makes managing the data in that database a little easier, because you could enter data directly into the database itself. We're just linked to that database. Okay, so trying to move on along here. One of the things that I find that so I'm going to be giving out a lot of user tips here, do's and don'ts, where users have gotten themselves into trouble over the years. And one of the things that happens is shortly after a user falls in love with the database library, like an Access database library, they immediately think, this is great, now we're ready to share the library. I'll just put it on a cloud drive like Dropbox or OneDrive or a Google Drive, and we'll start to share it. That will not work. Microsoft did not design Access to be used or synced in the cloud, and this is because it's a file-based database. Unlike sometimes people will say it's not a real database because it is file database. However, when it's placed on a company network or on your personal drive, it will behave and work very well, and it'll serve you well. The problem is it's not good for remote collaboration. Again, if you want to use an Access database, it needs to be on your personal computer or on your company network, and all the employees are at work connected to the company network, sitting in their cubicles or their office at work. If you try to put the Access database up on a cloud drive and sync it, you're going to get into a lot of problems with that. So if we look at the parts database again, one of the things you'll see in here is this LACCDB. That's a lock file. And in fact, you can examine those lock files simply by dragging and dropping that lock file to a text editor. Here I have Notepad++ on my machine. And if I open that file and look in it, we'll see that we've got a user on this machine here, and the person has admin privileges, and they're in the database right now. Okay. And if you were on a company network and you looked at this lock file, you would see the name of each machine and each user's name that's in the database at the time. But anyway, that's where the problem arises from, is because the lock file would also get synced to and from the sync drive in the cloud, and that's a problem. It just simply won't work. So anyway, a lot of users have tried to use Access that way. It will not work. And they've also tried to use it through VPN connections. That usually also fails. If you need to collaborate with a database for remote users, you need to use something like MySQL and host the MySQL session on a cloud service like Amazon Web Services or some other hosting service. Along those subject lines, also, if you want to follow this agenda, you can always find it over at PCBpartsblogspot.com. I'll be leaving a link down below later. But in there, you'll find links, for example, like if you are interested in trying out to create an Amazon MySQL remote database, you can click on these links here and you can find yourself over at Amazon Web Services, where you can get started with a free trial. You can get yourself a 1 year, 12 months free, 750 hours per month, and that's more than enough. 20 gigabytes of storage, way more than enough. I've never seen an Altium library exceed these requirements yet. So that's more than enough to get yourself a free library to use for a year. And but I always encourage people to start out with an Access database first. Just try it out, and once if you like that, it's very easy. At least if you download the parts application, you can very easily create scripts and export data up to your MySQL database and load the data. You can export from MySQL and you can load the data. All right, so let's see if we can get back on track here. Find my way back to the blog. All right, so we're going to be looking a little bit at Altium 365's managed components also. These are revision controlled libraries. So in addition to being version controlled libraries add one more layer in that they also, at the time you release your projects, you can do a revision check against the components in the design against the components in the library. We're going to look at how easy it is to migrate a database library up to an Altium 365 managed components. And the other thing I would really emphasize, though, the importance of cleaning up your data before you migrate to Altium 365 managed components, because it truly is a garbage in, garbage out situation where the data that you put into Altium 365's managed components is not going to be any better than the data that you had to import. So if you'd like to have consistent descriptions and symbols and layer usage in your footprints and stuff, you need to clean those libraries up before you migrate to Altium 365. Of course, you can clean up the library after it's been migrated. It's just that you'll find it to be quite a bit of work using that interface and continually doing releases of the revised and later revisions of the parts. So best policy is to clean up as much as you can before you do that. Also, we're going to take a look in here at some what I call polarity dots and some tips for creating your footprints. And we're going to have some tips in here for using supplier data, supplier one, some BOM tips. Anyway, enough about the agenda. Let me try to get going again. Okay, one of the first things I want to point out that you notice here that we get to see our part choice data here. We can see our supplier, and that's in that modal form. If we just go to the properties, scroll down, we can see we've got some data there. And I'm going to remove this integrated library. Remove, delete. All right, we'll see what happens there. If we do a refresh, interesting, it's still in there. I guess we're going to have to uninstall it. All right, so we'll go to our preferences, and then we'll just do a remove. So one of the things I want to touch on while we're here in the panel is that I have installed the demo database library. Again, you can get a free copy of that demo library over at PCBpartsblogspot.com. Not to worry, I'll leave a link down below that you can click later. But the important thing is that you understand that in these library based preferences, there's a hierarchy. And that is, there can be project libraries, which we don't have any for this project here at the time. There's the installed library where I've installed a dblib, this parts demo library, and then there can be the search path. And I highly recommend you stay away from the search path or be very careful when using search paths. For example, if you were to specify a search path that started at your root drive C, something like in just your root drive C, then Altium would end up searching every folder on your drive starting at the root drive C and through every subfolder. And this can take a lot of time and leave the user thinking that Altium is gone off in an endless loop or something. So I would recommend that unless you really know how to use that and you're limiting the folders that you're searching, just to be careful. Okay. So currently all I have in here, you can see all 0. That means we don't have an Altium 365 managed library set up yet, but we'll create one here soon. Right now we have just a database library, and notice in the database library that we see our symbol, we see our footprint, and we see some part choice data here. So the key to seeing this part choice data is simple. Some users aren't aware of this, but in your parameters, you need to be careful to use in your database a parameter called supplier 1 and supplier part number 1, these exact parameters. For example, let's change this parameter to supplier. Now let's look at this same part. Notice no part choices found. Okay. So let's put supplier 1 back in. Hit OK. And we can see our choices are back. And one more test is, let's just get rid of the 1 on supplier part number. Have another look. You can see no parts found. So it's important that the parameter name, whether you're using symbol-based concentric libraries, database libraries, or integrated libraries, if you would like to have this additional information show up, you're going to need to use the correct parameter names. And the parameter names would be, for example, supplier 1 and supplier part number 1. Okay. That's your first tip for the day on making sure you see and get the most from your data that you can. Okay, so at this point we're going to show how easy it would be. But before I go up there, I want to take another look at Active Bomb, which is a nice feature that Altium's introduced. And so I have 4 components in the design that are from Altium's content. And notice that those 4 resistors, the description fields, are pretty inconsistent. These are the 4 descriptions right here. And this is what the description fields look like coming out of the database library. Very consistent. Same thing for the capacitors, consistent. Anyway, so you can't get consistent data when using Altium content. So you pretty much need to, even if you start with Altium content, you're going to need to clean it up if you would like to have a professional looking outputs in your bill of materials, which I certainly do. So, back at the schematic level again, let's say these 4 part numbers were all placed from using manufacturer part searches. And the first thing you notice is, like, this particular part, the part number is listed in the comment. There is no manufacturer part number or listed here. There's no supplier listed. So anyway, they're just all hit and miss as to whether or not, and even the nomenclature, one might be 1K ohm, another one might be 1KR, and then those are those descriptions. Anyway, just be aware that, if you want to have professional looking results, you're going to need to clean up your own libraries. You can't just drop parts in from Altium content and expect to have professional results. All right, so next let's look at using parts, for example, to make some consistent parts. So in here, for example, if I have a 10K ohm resistor, and let's say that all of a sudden I wanted to make a 20K ohm resistor. Well, if it's going to be the same footprint, it's another 0402, it's going to use the same resistor symbol. And I've already got footprints that I'd like to reuse because I want to be consistent. So I would just simply jump over to Octopart. I might first start out by highlighting this part description, and here I'm going to do a search in Octopart for the part by description. So there it is. You can see the description was passed to Octopart, and I'm going to change this to well, let's make this a 2K ohm resistor. And so now that we've found some 2K ohm resistors, take a look around and we'll pick one out. I'll pick this one out from DigiKey for a moment, just see what that looks like. This looks like it's a test connectivity part. Okay, and we can see, yeah, it's an 0402. There's some stock. And so I'll just select make like. And so when we use make like, we're going to reuse the same symbol and footprint. And then over here at the DigiKey website, I'm going to press on my keyboard Control A. That'll select everything on my web page, and then I can just drag and drop that to the hat, and that will enter all the parametric data for me. Now you may notice that the data sheet's blank. It's because the data sheet web link or URL link is not displayed on the data in the data, so we need to do a separate drag and drop for that. And now we have our data sheet. Okay. All right, so anyway, that's all there was to making another part. So we had hit save, and when you hit save, several things were done. It was checking for duplicate part numbers. It was warning you if the part number, the part is RoHS compliant or not. If you choose those options, like you have options in here in the parts front end to alert the user if there's a duplicate part number or if it's RoHS compliant. Another thing about using an application like this that's important to understand is that a lot of times when you're cutting and pasting data from the internet, you might end up with carriage returns and line feeds. Like here, I'm going to try to enter a carriage return by holding down the control and the enter key. And notice we shifted the data down. And so anyway, you can get some strange things. But when we hit the save button in parts, all the leading and trailing spaces, extra spaces, carriage returns, line feeds, and troublesome characters that appear have been scrubbed from the description. And the description is entered in a very consistent manner. All right, so let's go back to our components panel, and we'll see that if we were to right click and do a refresh, we would have that new part added to our database, and we can place it into our design. And I'll just go ahead and update the PCB with that. But just for a moment, I'm going to uncheck these Altium parts because I want to show those to you separately. We'll execute changes. Okay, so we've just introduced R2. Not actually what I wanted to introduce. So let's try that again. I'll close this. I meant to introduce this one here, our question mark. So why don't we go ahead and annotate that first. I'll just do a quiet annotation. All right, so we got R15, and we'll push that over to the board. Again, I just want R15 for this demonstration. Okay. Design, import changes. R15. Execute. I think I hit close last time. All right, so we've got R15. So first thing we notice is that R15 is consistent with all the other footprints, and that's the other big advantage to using something like this. This is another tip for you. When I'm doing layout, because I'm going to place all the silk screening toward the end of the project, I like to do a scale and place all those silk screens to fit on the part. So anyway, that's pretty easy to do. We just change your height. I think I was using about 15 mils here. I'm using a stroke character, and that'll be about 3 mils of width. Go 3 mils. All right. And it was just centered. All right. Anyway, the point was is that we were able to very easily and quickly create another footprint and another symbol for our design by using a database library and using make-alike. And I'll be posting a link also down below where you can get a free demonstration copy of this library. And you can find it over at Parts blog, and just select the download tab and download the library there. And as I mentioned before, you'll have a complete working database library for free. It's not necessary to use a Parts front-end application like this, but it certainly will make your life a lot easier and managing the library a lot easier. For example, let's take a look at this configuration button in the Parts front end. We're going to open the Altium dblib file in Altium. So in Altium, if you load the dblib file, you can browse the same components that are over there in the database library. I'm just trying to find the ID. I like to keep that one near the front. Let me drag that over there. Maybe one more drag will do it. All right. So anyway, you can see these are the exact same parts that we were seeing over in the Parts front end. Started at 30,000 and ended in 30,023. And using a unique ID like this instead of a manufacturer's part number allows us to easily change the manufacturer part number. For example, let's say that we want to, there's no stock or something, and we want to now change this part number. Again, a good way to start out if we were using the Parts front end, but if you're not using the Parts front end, you can still do it. You just would go over to Octopart, but what I'm going to do here is it'll help me fill in the description at Octopart. So we're searching for another 2K ohm resistor, and we can see that we've got some inventory over here, some different part numbers. Yageo, for example, Vishay, Avnet. Let's see what else is here. Waslin. Back to Yageo. Anyway, why don't we take a look at this Mauser part, see what we get over there. All right, so now we're over at Mauser, and I've just decided I would like to use that. So one of the things I can do in the Parts front end is what's known as push the part numbers, and so I'm going to enable that and apply the changes. I'm going to hit Control A again on my keyboard, and I'm going to drag and drop this to the hat. And it's asking me would I like to change the part number, and I'll say OK. It's asking me would I like to push the part number. That's pushing the old part number over to part number 2. I'll say yes. So now I have a record of my old part number, and so in fact I have an alternate. So we could go back for example, and just even do that one more time. We'll go back to Octopart. Well, waiting for my browser to come free. All right, so let's have a look at this one. We'll pick something one more. Here's something with at DigiKey, another Yageo part. 2K ohm 0402. Control A to highlight everything. Drag and drop. It's asking us would we like to change the part number. We'll say okay. It's asking us would we like to push part numbers. We'll say yes. And now we've just we've changed our part number, and we've pushed our original part number all the way down to part number 3, and the last choice that we had just made a moment ago we pushed to number 2. All right, so now we have ourselves some alternate part numbers. It's pretty easy. All right, interesting. All right, close that. But before I leave here, I wanted to demonstrate that without a parts application front end, you would just simply load your DBlib and you would right click and you would add new components, delete components, you can open your symbol footprint. Anyway, this would be your interface that Altium gives you. I'm not going to go into that today, but that's something you can certainly explore on your own. You just need to download the parts database library, and if you would prefer to use Altium's built-in DBlib interface, you can do that, or you can always try out the parts front-end application. All right, again, we've added a couple manufacturers here, and we're going to go back into Altium. We're going to look in our components panel. We'll do another refresh, and this part has not been updated yet, so we would need to either update that part, but for the moment, I think I'll just place this part again. And if we look at our parameters, we'll see, hopefully, there's a couple more parameters. I don't see them yet. So let's try to do a refresh, see if that helps. Another place. We'll take a look again. Show. Put these in order. Maybe there we go. So we can see we have our manufacturer part numbers 2 and 3 in our manufacturer 2. Take a look at this one here one more time. I guess maybe it was there and I just wasn't paying attention. All right, so anyway, sometimes you need to refresh your library, obviously, after making changes. Now this one here, we never did update, so it wouldn't have them in there. We'll go ahead and do that once. Let's just update this component. So part actions would be to update selected from the library, finish, execute change, and if we look in there, we see our manufacturer 2 part numbers. All right. So now what I want to do is show you how easy it would be to migrate a database library up to Altium 365. So we could go here, we would just simply, with our database library loaded, we just simply select it, and there should be an action here somewhere for our library. It's been a little while since I've done this, so just bear with me. Import library. All right, so with our library selected here, we'll import our library. So remember, we got about 23 parts here in this little demo library. And Altium's done a good job of categorizing the parts for us, but a lot of that comes from the fact that the parts were originally well categorized in the database library. I should recommend you always hit the Advanced tab, and have a look around. And if you see any comments, like here we've got a question mark, it sees an uncategorized part. So if we look at that, we'll see component type none. And this is a template part that I'm using. Maybe I'll touch on that later, but right now I'm going to call that new. So I do have a component type in my preferences for types, one called new, and I like to use that to create my template. So after that, we can see that the parts have all been selected. We can hit validate, and also we can check our message panels, and if there's no comments, then you've had a clean validation. If you see messages there or comments out in here, then you know you've got some issues that need to be addressed, or should be addressed. Again, you could always, I guess, push the library up into Altium 365 with issues and clean it up there later if you want, but that might be more work than cleaning it up first. So we'll go ahead and select import. This will take less than a minute, so just bear with me. We're about 16 seconds into it, 15, 16 seconds. I expect it'll be done at about 45 seconds or so. It is kind of like watching grass grow. All right, so anyway, we've imported 24 components and imported 26 models. We could open the log and look at it if you want. It would just tell you what your success rate is, if it's ran into any problems. Okay. Close that. And to close the import, there's not a close button around here. You just simply select the tab and close the importer. All right, now when we look in our components panel, we can see that we've got 24 parts here. And what I'm going to do is go down and take a look at that last part that we placed. It was the 2K ohm resistor. If we look at that in the properties panel, we can see our part choices. So we can see our alternate parts. We can see our parameters, and we know that we've got nice and clean, consistent descriptions. So we've got a pretty quick and easy migration into Altium from a database library when you start out with a clean database library. Okay, so let's look at a couple more interesting tips that I have to share with people today. And one of them I think I'll jump onto is the footprint next. Like I said, we're going to have a few different user tips, so stick around. I think a lot of you are going to find some of these tips to be very useful. Notice that when you're done laying out a board, sometimes one of the things you do toward the end is you need to clean up your silk screen. And the polarity markers sometimes will end up in the wrong place. For example, you'll have a polarity marker over here and you've added your decoupling cap and now you have a violation. And you'd like to be able to move that polarity mark. Well, have you noticed how easy this polarity mark is being moved around? Typically what you would have to do in Altium is you would have to open your properties panel. You would have to unlock your primitives. And then after you've unlocked the primitives, you would move your polarity mark, and then you would lock your primitives very carefully again. And that adds quite a few extra steps to the process. So I was pretty pleased when I stumbled into this idea. Was looking around on the forum one day, and someone suggested using a period and a text string. Well, I tried that. I didn't like the looks of the period. But I found something that looks very nice. As you can see, it makes a very nice arc. It's also very scalable. What is it? Well, it's the letter O, and it's a small case O. So, example, there's an uppercase O. So it probably really doesn't matter whether it's an uppercase O or a lowercase o, but I happen to have a lowercase o in there. And then let's change our stroke width. Now notice here that we have text height of 0. That's right, 0. That's how we're able to get a nice circle out of it. And then we have our stroke width. Let's make that a little smaller, for example. I'm going to take it down to 0.3. And you can see now we have a smaller character. Very easy to push around. And that's because it's as easy to push around as Silkscreen is, because it's also text. And you can see that we can move that around, and we also know which component it's associated with. The same thing here as soon as we start to move our polarity dot, but we don't have any of those issues about having to unlock the primitives. So that's a pretty nice find, if you will. I'll be converting all of my library's polarity markers to be using this small k, or this letter O. Just remember your text height needs to be 0. Let's look at that. If you give it some text height, so you can see it kind of gets distorted and starts taking on an octagon shape. Again, the trick here is to just use a 0 text height and use whatever width you want, and you'll end up with a nice circle. And you can grab it and shrink it down. Of course, you can rotate it, but there wouldn't be much sense in rotating something that's a circle, but certainly can rotate it. But the beauty of it is, like I say, is if your silk screen ends up in the wrong place, when it comes time to clean up your silk screen, you can just grab it and move it without all those extra steps. All right, let's see what else we can cover with you today. So we're about 40 minutes into it, and I'm sure most of you are starting to lose interest, probably glazed over by now. So I think I'm going to call it a day. Thanks for watching the video. If you'd like to discuss any of these other points with me, you can always contact me at Parts. Be happy to give you a free, no-hassle demonstration. I don't capture your email address, follow up with spam. I don't follow up with promotional. Simply give you a demonstration, and I never contact you again. If you're interested in Parts, you'll need to contact me over at Parts. I will not be following up with your email addresses with promotional material. Thanks again for watching the video. I hope some of these tips were useful to you. Have a great day. Thanks for watching the video. And as always, if you're interested, you can jump over to Parts, download Parts, try it out for yourself. If nothing else, you get yourself a free database library. And you can always select Contact Parts, leave your email, your name and email address if you'd like for me to get back to you and give you a demonstration. Thanks again. Have a great day.